Alright guys, thanks for tuning into a video on step functions. So our aim or our goal today is to graph step functions, and we're also going to look at some real world examples. So first off, a step function is a graph that resembles a set of stairs or stair steps. So that is why it's called a step function, because it looks like stair steps. So as it increases or decreases abruptly, which means it kind of jumps around, from one constant value to another. Okay, so I will show you an example of one. So here is what it will look like. So I have f of x, so I've got same thing, that's just like a y value. So it's like y equals the following numbers, and then it's going to give me a domain restriction for each of these. So notice this looks like domain and range. That we've done in the past, that less than or equal to sign is going to be a closed circle, if you can remember from inequalities. And then this less than sign would be an open circle since there was no line underneath it. Okay, so the first off, you're going to go to a -2 on your y value. And so on the y-axis, a -2 would be right here. Now you don't make a point yet, because then you need to look at the range value. So the domain can be from a 0 to a 2. So I'm going to go to where y is -2, and it can be at 0. So I'm going to make a point, closed in, because it can be equal to 0. And then I'm going to draw a line all the way until a 2 on the x value. Okay, so I went from a 0 on the x to a 2 on the x, and then I need another circle, and it needs to be opened because it could not be equal to it. So there's my first off set of staircases. Then I need to come to the second one and go where y is a -4. So 1, 2, 3, 4. And then I need to look at my domain. And this one I'm going to start at a 2 and go to a 4 on the x-axis. So if I go down to a -4, I need to pick up kind of where I left off and put a closed circle below this one, because that's where x is a 2. Okay. Then I'm going to go all the way over until a 4, and I'm going to go open circle on a 4. So I'm going to draw a line, another stair step, and go open circle. Okay, so notice when you have an open circle here, it's going to be closed below it, and etc. So lastly, I'm going to go to a -6 on the y-axis, which should be right here. I'm going to start at a 4 and make it a closed circle. And I'm going to go all the way to 6 and make it an open circle since it did not have a line. Okay, so this is what the graph of a step function looks like. You can have multiple stair steps, or you can have just 3 or 1, but that is what a step function graph looks like. So if you think you understand that, go ahead and try number 2 on your own. If you would like me to kind of walk you through this one again, stay tuned. So if you want to try on your own, press pause right now. All right, so I'm going to walk you guys through this one. So if you tried it on your own, please skip ahead. So first off, these are my y values. So I'm going to go where y is a 1. And so here is a y of 1. And then I want to start at 0, but I want it to be an open circle. So I'm going to go to 1 and make an open circle. And I want that line to go from a 0 to a 1 on the x-axis. So I'm just going to go over 1. And then make a closed-in circle. So we've got a kind of a small step right there. Then I'm going to go where y is a 3. So 1, 2, 3 on the y-axis. I'm going to start off where x is a 1, so an open circle. And then it's only 1 lengthwise. And then it goes to a 2 on the x-axis, closed. So I'm going to go to y4 now. So 1, 2, 3, 4. And I'm going to start at a 2, closed, or open actually, and go over 1 into a 3, make it a closed one. And then I'm going to go to where y is a 6, 1, 2, 3, 4, 5, 6. I'm going to start at 3, 1, 2, 3, make it an open circle, and draw your line to your closed circle. Okay, so again, this is what you should have got for number 2. Notice you can kind of have some gaps in between it. The stairs don't even have to be evenly spaced out, but just make sure that if one circle is closed, the other one above it or below it is going to be open, because these are still functions. Okay. All right, so that's how you graph step functions. Why is my mouse not working? There we go. Okay. Now we're going to look at some real-world problems. So you have a school is going to charter buses so that students can attend a football game. Go Falcons. Each bus holds a maximum of 60 students, and we're going to make a graph that models the relationship between the number of students, X, that go to the game by bus and the number of buses that are needed, Y. So first off, here is the X-axis, and here is my Y-axis. So I need to label the X-axis, and since it says X is the number of students, I'm going to put number of students down here. My Y-axis is going to be the number of buses, so I'm going to put number of buses right there. All right, so then I have each bus holding a maximum of 60 students. So I need to go all the way up to 60 on my graph, or go by 60s for each bus. So I'm going to start off right here and say this would mean 60. 60 plus 60 is 120. I'm actually going to space this out more to give us more room. So 60 will be here, 120 here, we'll skip a spot. 180 would be the next one if you added 60. 180 plus 60 is 240. And then we would have 300. Okay. On my y-axis, I just need to do number of buses, so let's just go 1, 2, 3, 4. Put 5 up here if we need to. Okay. All right, so now I need to fill in my step graph. So each bus can only hold 60 students. So if I am at bus number 1 over here, I shouldn't have any students, because 0 would mean no students are on the bus, so it'd be the open circle. And then I can have up to 60. So I can have all the way up to 60 on this one bus, okay? But if I have anything past 60, I'm going to have to put them on a different bus. So if I'm at 61, for example, that would hop up to bus 2. So what we do is we go right above it and give an open circle representing that 60 will not be on bus number 2, but 61 could be. So anything after it. And then from 60 to 120 students can be on that second bus, okay? But if you have 121, you're going to have to go by another bus. So we're going to hop up to bus 3. So that open circle means that is not 120, but is like 121. We're going to continue all the way for another 60 until the other bus, okay? So notice a pattern. You're going to have to keep stair-stepping. If you have a circle below it, the circle above it is open, and then you just continue for every 60 student, okay? So, if you were to evaluate, for example, if they said, if I had, let's see, 200 students, how many buses is that? Okay, so what you would do is you would find 200 on the graph, which would probably be somewhere up here, and that means I would have to have 4 buses. Okay, so that's kind of how you read a step function if it asks you to interpret it or asks for how many students. So if I had 240 students, you would go up and you would say, hey, I'd have to have 4 buses, but you would not go up to the circle because it can't be equal to it. All right, so that's how you graph a step function from a real-world problem. And now it's time for you guys to practice. So you've got 2 problems. You've got a normal basic graph where it wants you to graph the step function, and then you have a real-world problem down here. So I want you to press pause and try these 2 on your own, and then we will go over them. Number 4, first off, you had to go to where y was a -1, which was right here, and notice this time we started at x as a -2, so you had to go over left 2 to make your closed circle. It went all the way to a +1, so this is kind of a long step, and then open circle on +1. Then you just kind of dropped down 1 and continued that stair step, noting that it went from 1 to 3, and then 3 to 6, and then 6 to 8. Okay, so if you need any help graphing a step function in function notation, please let me know. Otherwise, I'm going to actually walk us through this one because real world problems are a little bit harder. So first off, you had to label your axis. And here is the x-axis, and here was the y-axis. So your x-axis was number of people. And your y-axis was number of tables. After that, you kind of had to figure a number to go by on the x-axis and the y-axis. And it says the people are going to the bar mitzvah. Each table holds a maximum of 10 people. So for every table you had 10 people, so let's go by tens. So 10, 20, 30, 40, 50, 60. Okay, so that's one way of doing it, is going directly. Or I'm going to show you different ways you could have skipped some steps and kind of skipped some lines. So you could have said this was 10, 20, 30, 40, 50. So it's kind of up to you how much you want to fit in a graph. And then for the tables, we're going to go by ones. So 1, 2, 3, 4, 5. Okay, so this is going to give you half the graph if you skip some lines. So first off, if you have 10 people, again, you don't have anyone sitting at a table by themselves yet, so it's open, but you can have up to 10, including 10 on the first table. At that second table, you could not have 10, so it's open, but you can have all the way up to 20 people. Same thing, bump up 1. You can have all the way to 30, included at 3 tables. Bump up, open. You can have 40 people, and etc. Okay, so this is one example of a real-world problem. Again, if you went by 10s, 20s, 30s, 40s, 50s, your graph would have more information and be a little bit smaller, but you would still get the same concept. Okay, so let me know if you have any questions on real-world step functions or graphing them. If not, you can practice, and thank you for watching.